Okay, so if you want to be successful in mathematics, it's an absolute must that you know how to work with square roots, cube roots, powers, and exponents because these are everywhere in math. And if you really understand all the rules with roots and powers and exponents, then this should be a pretty easy problem to do without the aid of a calculator. But a lot of people are not going to be able to figure this out because they don't understand these concepts well enough. But let's see how you do with this problem. Again, the only rule here is no calculator. The problem is we want to take the cube root of the square root of 1 over 64. And if you know how to solve this problem, well, put your answer into the comment section. I'll share the correct answer in just 1 second, and then I'm going to review the real critical principles that you need to know in mathematics to solve this problem. And I'm actually going to solve this problem in two ways. Okay, but before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And it really is my true passion to try to make learning mathematics as easy as possible. So if you need assistance in math, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to hit that like button and that subscribe button, as that definitely helps me out. Okay, so many won't know the answer, but maybe you got this correct. Let's go ahead and take a look at the correct answer, and that would be 1/2. All right, so how did you do? Well, if you got this right, that is very impressive. Matter of fact, I'm going to give you a nice little happy face, an A plus, a 100%, and multiple stars. Matter of fact, if you were in my math class, I would just say, you're so smart, just take the rest of the year off. I don't know how you're learning all this math. Maybe you're watching that guy on YouTube. I don't know. But anyways, all jokes aside, if you are like lost, you're like, I have no idea what's going on here. Well, let's go ahead and get you some basic knowledge on powers and exponents, right? So let's go ahead and get started right now. And what I want to do first is take a look at this problem and just review what we're dealing with here, right? So we have a cube root, which is different than a square root. So most of you, if I say, well, find the square root of 4, you would say, well, that is going to be 2, right? This is technically what we call the principal square root. And what we're saying here is when we ask ourselves, or we look at a question like, what's the square root of a number, like the square root of 4? Well, the answer is 2 because 2 times 2 is, of course, 4. Okay, let's go ahead and just do another problem here, but we're going to use the cube root right now. So we'll use the cube root because obviously we're going to be dealing with the cube root here, but let's do something easy, the cube root of 8. So if the question here, the square root of 4, was, hey, find a number such that you multiply it by itself, you get back to this number, well, that number is 2. So what does a cube root mean? Well, it means find a number such that when you multiply it by itself 3 times, we get back to 8. Now, of course, that would also be 2. 2 times 2 times 2 is 8, so the cube root of 8 is 2. Now, most people, I think, understand that. But what we need to do to solve this particular problem, to make our life a lot easier, is to understand something called rational exponents. And we're going to need a few other things as well. But let's start off first by reviewing what a rational exponent is. Okay, so in mathematics, in algebra, what we can do is write a cube root, for example, in a different way. So we can write it this way, 4 to the 1/3 power, okay? Now this little exponent here, now let's just recall like 2 to the 5th power. This little number here is called an exponent, and this big number down here is called the base. The entire thing is a power. So what we're talking about here is something called rational exponents. Rational exponents. So our exponents are what we call rational numbers, which effectively are fractions in mathematics. Okay, fractions that can make up of integers. So this is the topic. So if some of you are actually taking an algebra course or a math course, and you're like, well, where do I go in this course to review what I'm talking about here? Again, you're talking about roots, powers, and rational exponents. But again, what we can do here is write a cube root, for example, using rational exponents. So let's just see what the pattern here is. So this little number, 3, becomes the denominator, and it's 1 over this. Okay, let's go ahead and see another example. So what's the fifth root of 4? Well, if you're saying to yourself, was it 4 to the 1/5 power? Yes, indeed. You get the idea. That is how you write rational exponents. So here's a square root of 4. Okay, you might be saying, well, where's the number? I don't see the number here. Well, the square root is actually a 2 right here. Okay, we don't say, or we don't write a 2, but there is a 2 there, so this is going to be 4 to the 1/2 power. So if you have your calculator, just want to kind of, verify what I'm saying, go ahead and put into your calculator 4 parentheses, and you'll have to find your power button, but it's typically something like this, to the 1 divided by 2, and use parentheses when you are always taking the powers. You power something with rational exponents. So 4 to the 1/2 power, you'll see, indeed is 2, right? Because we're talking about the square root of 4. Okay, so this is the first thing that we want to know, and that, of course, is that we can write roots, square roots, cube roots, whatever, fifth roots, doesn't make a difference, as rational exponents. So this is going to come in very handy. All right, let's go ahead and take a look at some other things that we need to understand about powers and exponents, because now we're going from things like the fifth root, and we're writing this in terms of an exponent, right? So let's say this is x, so x to the 1/5 power. So it's probably a good idea to know a few principles, and these are not all the things that you need to know about properties of powers and exponents, but these are the ones that we're going to need for this particular problem. And the first one is a to the m to the n. So what does this mean? Well, if we have a power, so we have a power with some exponent here, and we take that to another power, we raise that to another power, which would be an outside exponent. Well, this is going to be simply equal to a to the m times n. Now, algebraically, you might not understand what's going on here, so let's take a look at a few examples. Okay, so 2 cubed squared is going to be equal to 2. This is our outside exponent, or n. We're just going to simply multiply by the inside exponent, 3. So that would be 2 to the 6. Now let's just think about this. Why would this make sense? Well, 2 cubed is what? 2 times 2 times 2. This is 2 cubed right here. And we want to square this, right? So in other words, we're going to multiply this thing by itself. So that's another 2 times 2 times 2. And we see, how many 2's do we have here? Well, indeed, we have 6. So, oftentimes when you look at a property or a law in algebra or mathematics, if you just understand simple examples, you'll see, oh, these laws, totally make sense. And if you forget them, oftentimes you can kind of re-engineer what the law is, just in case if you forget the formal properties, or, the formulas per se. You could just kind of, think about, oh, yeah, this makes sense. Let's go ahead and see another example here using rational exponents. So 2 to the 1/3 power, 2 to the 1/3 power to the 6th power. So we're just going to multiply that 6 times 1/3. So this would be equal to 2 squared. All right, so this is another thing that we want to use for this particular problem. And there's one other property, and this one gives a lot of students some confusion, and that is powers to the negative exponent. So the rule a to the negative n is equal to 1 over a to the n. What does that mean? Well, let's take a look at some examples. So 2 to the negative third power is equal to 1 over 2 to the third power. So notice here, anything with a negative exponent, you can get rid of the negative exponent by basically putting it on the opposite side of the fraction bar, okay? Now, let me just show you this property right here, and we'll take a look at these other examples more closely. But if I have a to the negative n, and I want to think of this as a fraction, I could just put it over 1. So if I want to get rid of a power, if I want to get or change a power with a negative exponent, I can just put that same entire power right here, put it to the opposite side of the fraction bar, and the sign of the exponent changes. So this becomes a to the positive n. Okay, so here 2 to the negative third power. I'm like, well, I don't like negative exponents. Well, just write this on the opposite side, so that 1 over 2 to the positive third power. Now, what if I had 1 over 2 to the negative 3 power, just like I have in this case? Well, to make this positive, just put this up into the numerator. So I would have 2 to the positive third power. Okay, now if you are a bit confused, and this can be confusing, certainly what I'm doing here is just doing some quick review about these properties and exponents. Let me give you a few suggestions. One, to get like my best full instruction on this, check out my algebra courses. You'll find links to those in the description below. And you probably want to look at my Algebra 1 or Algebra 2 course to get complete instruction, especially on rational exponents. But also I have a ton of additional videos on my YouTube channel as well. Okay, so let's go ahead and take the next step, and that would, of course, have you subscribe to my YouTube channel. Now, I wouldn't ask if it wouldn't have that much impact on my channel and actually on my goal. Now, what is my goal? My goal is to grow my channel, but really my goal is to reach as many people that are interested in mathematics or especially need help in math. I am trying to prevent people from giving up on mathematics, and this is such an all too common scenario. A lot of people say, you know what, I'm failing my math test. I can't be that smart because I just don't understand what's going on. Listen, 99% of the time, that is not your fault. Okay, it's more, well, it can be your fault if you're not putting in effort. But a lot of people do put in the effort. They really want to learn, but they're not getting adequate instruction. Okay, and that means clear and understandable and comprehensive math instruction. If you're not getting that kind of instruction, you're going to have a tough time learning mathematics. Okay, so make sure you find someone that can teach you in a manner that you like and understand. And if you can't find anybody, well, I'll be your math teacher. Okay, so anyways, by you subscribing, it does help me find those people that are getting frustrated with math. If you're going to subscribe, make sure to hit that notification bell as well so you can get my latest videos. Thank you so much for listening to my little commercial here, but it is important. This is how you support my channel. Okay, so let's get back to this problem and put everything together. Okay. So the first thing I'm going to do here is I'm going to write this cube root of a square root, and I got a fraction here. I'm going to write this using rational exponents, So let's go ahead and just take a look at the inside. This is the square root of 1 over 64. So I can write this as 1 over 64 parentheses. Okay, you want to put this in parentheses to the 1/2 power. Okay, so again, this right here, of course, is the square root of 1 over 64. Now, all of this is going to be taken to the 1/3 power because we're trying to find the cube root of this answer. Okay, so to do this problem without using rational exponents, we would try to figure this answer out, and then we would take the cube root of that. Okay, so let me just go and erase this here so you can kind of see that this is what we want to do. We want to take this expression with these roots here and write it this way. Okay, it's going to make this problem much easier. All right, now at this point, there are a few different options that we can take. I'm going to show you two good options. So the first thing is, let's take a look at 1 over 64. Now, I didn't mention this initially in terms of things that you need to know about square roots, but let me go ahead and show you what we could do here. So let's take a look at 1 over 64, and this is to the 1/2 power. So we know, even if I write it this way, we know that we're trying to find the square root of 1 over 64. Now, even though I have written the problem using rational exponents, I could still say to myself, okay, what is the square root of 1 over 64? So if I write the square root of 1 over 64, I can break up this one big square root into two separate square roots. This is a property. It's another property. I can just write it, and let me just write it over here. Another property is another property, of powers and exponents. So it would be something like this. The square root of a over b is equal to the square root of a over the square root of b. All right, so when I do this, though, I can basically evaluate this pretty easily because now instead of the square root of 1 over 64, I have the square root of 1 over the square root of 64, which of course the square root of 1 is 1, and the square root of 64 is 8. Okay, so 1 over 64 to the 1/2 power is equal to 1/8. All right, so now we can go ahead and rewrite this problem this way. So I have this 1 over 64 to the 1/2 power. Well, all this now is equal to 1/8. So all I have to do is figure out, well, what is 1/8 to the 1/3 power? Which, of course, if I want to write this back into forms using radicals, this would be what? Well, this is the cube root of 1 over 8. And we do kind of, even though we may not go back into this notation, you still always want to think about these rational exponents as roots as well. Okay, all right, so let's go ahead and take a look at this. So what is the cube root of 1 over 8? Well, we can use the same property. Okay, this thing here I just showed you, the square root of a over b is equal to the square root of a over the square root of b. Same thing applies with any root. Okay, cube root, fifth root, doesn't make a difference. So I could break up this one big root into two smaller roots, okay, one in the numerator, one in the denominator. So the cube root of 1 over 8 is equal to the cube root of 1 over the cube root of 8, and the cube root of 1 is 1, right? 1 times 1 times 1, of course, is going to be 1, and the cube root of 8 is 2, and we did that problem earlier in the video, so our final answer is 1/2. Okay, so that is one approach you could take, but there is another approach, and really this is the approach that I'm going to hope many of you can remember. Okay, now what I just covered is, still valid and good, but here is kind of a better way to do this problem. So anytime you see something and you're working with rational exponents, you always want to try to express numbers, if possible, okay, as powers. Okay, so for example, if I have 64, actually let's use something simpler here. Let's take 8, okay? So I have the number 8. Well, all right, how can I express this as a power? Easy, just write that as 2 to the 3rd power. If I see 4, I would want to think of this as 2 squared. If I see 16, you get the idea. This would be 2 to the 4th. If I see 25, you want to think of this as 5 squared, etc., etc., etc. So when you see things like 64, okay, you just don't want to write 64 as, you might say, well, that's 8 squared. Well, that's good, but remember 8 is also 2 cubed, okay? 2 cubed squared is 2 to the 6th. So when you think of numbers as powers, you want to use the smallest base possible. Okay, so again, a lot of these numbers are pretty common. If you encounter a problem like this on a math test or quiz and there's no calculator allowed, the numbers are going to be pretty, easy to work with. Okay, so 1 over 64 is equal to 1 over 2 to the 6th power. Now, I want you to do another thing here, is don't leave your answer as a fraction. Okay, let's use this property, a to the negative n, to kind of consolidate this, a to the negative n over 1 over a to the n, excuse me. So let's consolidate this, let's get rid of a fraction and just consolidate this as a simple power in exponents. So this is going to be equal to 2 to the negative 6. Okay, so 1 over 2 to the 6 is the same thing as 2 to the negative 6. So hopefully you're with me. Okay, so now we're going to use this 2 to the negative 6 to make our life a lot easier. Okay, so right here we figured out that we have 1 over 64, and we wrote this whole thing as 2 to the negative 6. So this is all right here, 2 to the negative 6, and we're going to take this to the 1/2 to the 1/3. All right, so here we go. So we have 2 to the negative 6. All this is going to be taken to the 1/2 to the 1/3. And now this is just one big multiplication problem because we just have all these exponents we have to basically clean up, right? So let's go ahead and deal with this right now. So we'll handle these exponents, these outside exponents. So 1/2 times 1/3 is going to be 1/6. So 2 to the negative 6 times 1/6 is what? Well, 2 to the negative 6 times 1/6 is going to be 2 to the negative 1. And of course, we can write this as 1 over 2 to the 1st. Okay, and in mathematics, it's pretty much, well, we call this kind of a convention, but it's kind of accepted that you don't want to leave your answers your final answers with negative exponents. So if you gave this to your teacher, they would, possibly are going to be upset and take some points off. You don't want that to happen. So always express your final answers with powers and exponents with positive exponents. Okay, so take this 2 to the negative 1 and write it as 2 over 2 to, well, I'm sorry, 1 over 2 to the first positive 1, which of course is 2, or 1 over 2, or the fraction 1/2. Okay, so hopefully, this wasn't too confusing for those of you out there that, maybe, forgot all this stuff. I kind of threw a lot at you in one video, but, I think most of you will understand this. And here's the thing. Don't expect to understand math, for the most part, when you go through one lesson or you do one problem. It takes multiple times, so, over and over again. That's very normal. So if you're like, oh, wow, I watched a full lesson on something, or, or even this video, for example, you watch it and you're like, well, I don't really get it. Well, again, give yourself a couple times to absorb the information. Okay, this is a lot of information. But once you understand one problem, you really understand what's going on, then you can apply all that knowledge and skills and comprehension to do other problems. Okay, so with all that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.